Okay, guys, welcome back to day 2 of piecewise functions. Today we're going to be doing is graphing piecewise functions. Okay, so yesterday we learned how to evaluate. So today what we're going to do is learn how to actually graph those functions. So make sure you have your Springboard book. We are starting on page 57, something to write with, and a calculator. Okay, so let's look at an example of a graph of a piecewise function. So this says the graphs of both y equals x minus 2 for x values less than 3 and y equals negative 2x plus 7 for x values greater than or equal to 3 are shown on the same grid below. So what a piecewise function is actually multiple graphs. So let me kind of color code this here. It's multiple graphs that are kind of just pieces of each that they put together for one picture. Okay. So for example, when x is 3, that's when the two graphs shift from one to the other. So right here, here's 1, 2, 3 on the x. So you see how the graphs kind of are two different lines there? Okay. So what they're saying is when x is less than 3, so remember less than is when the graph is to the left, less than left. They're using this function, y is equal to x minus 2. So there's like your y-intercept at negative 2. So there's that piece of the graph. Now the graph's going to switch when x values go greater than or equal to 3, and they're going to switch to this other equation, the negative 2x plus 7. Okay, so what this is that a certain domain value, a certain value for x, those are your domain restrictions that we talked about in the last video, the graph is going to shift from one line or one function to the other. Okay, so I know this graph kind of looks like a V at first, but when we actually break it down, it's actually two separate functions that are pieced together. And so it's called a piecewise function. Okay, so I'm going to jump to the next page really quick and just talk about the piecewise function definition, which we went over yesterday, but I just kind of want to go over this again in terms of graphing. Okay, so we're going to have our piecewise function, okay, and it has your 2 or 3, whatever it is, function rules to it, right, that we learned yesterday. So what we're going to do is we're going to graph each piece, but only at the domain restriction. So when we actually start graphing these, I call these things the fences. Okay, so the fence in this case is going to tell us where one function stops and the next function starts. Just like at your house, your fence would tell you where your neighbor's yard stops and your yard starts. Okay, so the fence is kind of our divider and kind of tells us where the lines are going to pair off. Okay, so if I go back to the first page, and we're going to graph these functions for number 3. I'm going to show you 2 ways to do it. So one way is to use these tables. We're going to make a table of value for each function. So what we have here is we have the function x squared minus 3 when x is less than or equal to 0. Okay, and then we have the function y equals 1/4 x plus 1 when x is greater than 0. Okay, so again, those restrictions right there, that's my fence. So what that tells me is that's where the one line is going to switch from one function to the other. So what I always do is I start there and I draw a vertical line at that x value. So there's where x would be 0. Okay, so what we're going to do is we just have to kind of make our xy table, but I'm going to pick numbers based on what side of the fence my function belongs. So, for example, y is x squared minus 3 when x values are less than or equal to 0. So less than is going to be on the left side, so like this. So one value I tell you always have to pick is the fence. So I have to pick 0. But then you can pick any other values after that as long as they're on the correct side of your fence. So in this case, I could pick any x value that is less than 0. So let's say we pick negative 1 and negative 2. Okay, pick 3 points. You can always pick more if you're nervous. And what I'm going to do is plug those in. So if I plug in 0 into my function, the green function only, 0 squared, so I'll show my work for one of them, and then minus 3. Well, 0 squared is 0, minus 3 is going to give me negative 3. Okay? If I plug in the next one, that means I'd have to take negative 1, square it, and then subtract 3. Well, what's negative 1 times negative 1? That's positive 1, right? Minus 3 gives me negative 2. Okay, and if I do the same thing with the last value I picked, negative 2, if I square that, what's negative 2 squared? Well, that will give me positive 4. Negative 2 times negative 2. Minus 3 is a 1. Okay, so I'm going to go ahead and plot those points. We have 0, negative 3. I have negative 1, negative 2. And I have negative 2, 1. Now, if you know anything about an x squared equation, a quadratic equation, it's that parabola shape, so it does kind of have a curve to it. So if I connect the dots, it's going to look something like this. Now, the more points you pick, the more accurate your picture is going to be, but we kind of get the idea from that side. Okay? All right. So looking at the right side of my fence now, we have 1/4 x plus 1. So we're going to pick x values to plug in. Again, I always have to choose my fence. And then I'm just going to pick any other x values I want as long as they're on the correct side of my fence. So in this case, I can pick any x value that's greater than 0. So I'm going to be a little smart here because I have a 1/4. So I'm maybe going to pick 4, and I'm going to pick 8 because both of those are divisible by 4, and that'll make my life a lot easier. Okay. So now let's plug it in and see what we get. So if I have 1/4 times 0, that's 0, plus 1 gives me 1. If I take 1/4 of 4 plus 1, 1/4 of 4 is 1. 1 plus 1 is 2. Okay. If I take 1/4 times 8, okay, well, 1/4 of 8 is 2. 2 plus 1 is 3. So if I plot these points, 0, 1, 4, 2. Now this one's going to go off the graph, so I'm just going to do the best I can. 8, 3 might be about here. Okay. Now if I left the graph like this, I have a little bit of a problem, which I think we talk about on one of the next slides. But if you know anything about functions, remember, in order to be a function, something has to pass the vertical line test. So if I draw a quick little example here, a graph like this would not be a function because if I drew a vertical line, it hits more than one time. So this would be not a function. So on our graph that I just did, technically right here on the fence makes it not a function because we have a blue dot and a green dot. So here's how we fix that. It's all based on the inequality. So I have x is less than or equal to 0 for the green graph. That means since it's equal to, it gets a solid line or a solid circle. On my blue line, it was only for x values greater than 0. So anytime we just have strictly greater than, we would use an open circle. So now this graph is actually only defined at the closed circle, and you have an open circle on the other function. So now it's technically a function. So we're going to deal more with that later, but that is our function. Okay, so again, a piecewise function is two separate functions pieced together on one graph. So let's just do another one. I'm going to jump to the bottom of the next page right here. Now your book had a table. I didn't like their table. I like making two separate functions or two separate tables for each function. So that's kind of what I do, but here we go. So here's our piecewise function, and it's written kind of a little neater than the first one using the brackets. But we have g of x is negative 2x minus 1 when x is less than negative 1. And then we have x plus 3 when x is greater than or equal to negative 1. So again, this spot here, that's your domain restriction. So when we graph it, this is where we put our fence. Okay. So on the x value at -1, I'm going to draw that vertical line right here. So that kind of cuts my graph in half. So I know that one function goes on the left side of the fence, one function goes on the right side of the fence. And how we tell is just from the inequalities. Okay. So we have when x is less than 1, so on the left side, we have this function, -2x minus 2. And when x is greater than or bigger than -1, which is the right side of my fence, we're going to have the function x plus 3. So that's how our graphs are going to switch from one function, it's going to hit the fence, and then the other function picks up. So let's make our table for each. So on the left side, again, you have to pick the fence. So I have to pick -1, but then just pick any other number that's on the correct side of your fence. Again, this green line can only be on the left side. So I have to pick numbers that are less than or smaller than -1. So maybe let's pick -2 and -4. It doesn't matter what you pick. I'm just picking random numbers that I know are smaller than -1. Now, if the arithmetic is too much for you, you can always just punch it in the calculator. Your calculator is very smart and it knows all the order of operations. I'm going to load mine here really quick so you can see that. So for example, we have the function -2x minus 2. So -2. So for x, if I plug in -1 and then -2, it should give you my answer. What do we get? We get 0. Same thing if I do the next one. We have -2 times -2 minus 2. What do we get? +2. And the last number I picked was -4. So -2 times -4 minus 2 gives me +6. So that is my green graph, my left side. So let's plot those points. So we have -4, 6. I have -2, 2. Now this last one I'm going to be really careful about because on my fence, we have to put an open or a closed circle. So since we just have x is less than -1, that means I'm going to put an open circle on this value. Okay, open circle. So at -1, 0, we have an open circle. And there's half of our graph. All right, I'm going to do the right side a little faster. So again, we have to pick the fence. We have to know where our closed circle goes. And then I can pick any numbers that are greater than -1. So maybe I'll pick 0 and 2. Okay, so again, the only value you have to pick is the fence value. After that, the choice is yours. But let's plug it in. -1 plus 3, that's going to give me 2. 0 plus 3, that's 3. 2 plus 3, that's 5. So at -1, 2, that's where I get the closed circle because of the equal to. 0, 3, that's my next point, 2, 5. So there is our piecewise graph. It's two graphs pieced together to form one picture around one kind of domain restriction. Okay. Okay, I'm only going to do maybe a couple more, so I'm going to jump to this page here, page 59. We're going to look at graph A. So we have f of x is x plus 2 when x is less than 0, and 2x minus 1 when x is greater than or equal to 0. So again, I'm going to put in my fence at my restriction here. So at 0 is where my graph shifts from one function to the other. Okay, so since it's less than 0, I'm already going to kind of remind myself that's going to be an open circle. Greater than or equal to 0 will be my closed circle. So on the less than side on my fence, I know x plus 2 is going to go. And then on my right greater than side, it's going to be where we put 2x minus 1. So here's another way to graph it if you don't like using the table of values. okay, because that's the way is a little longer. So if you're good with graphing, then I would suggest using the slope, okay? So what you're going to do is figure out where on the fence these open and closed circles go. So again, my fence is 0. So let me keep this color coded, go green. So my fence is 0. So if I plug in 0, what do I get? I get 0 plus 2, which is 2. So on that value, I'm going to put an open circle. Okay. Now I can kind of use the slope to graph the rest of the line for me instead of making more points. Now you're more than welcome to still use the table, but here's how we can use the slope. Now technically there's a little imaginary 1 in front of there, right? So we're used to saying that our slope would go up 1 and over 1. Okay, but the problem on the left side is I can't cross the fence. I'm not allowed on the right side. So instead of going up 1 and right 1, I'm just going to go opposite. I'm going to go down 1 and over 1 like this. Okay. It's still the same line if I was to go up and over. But remember, this green graph is not allowed to cross the fence. It can only be for x values less than 0. So I couldn't go that way. So instead, I just went downwards. Okay. On my other side of the equation, if I plugged in my fence value of 0, what would we get? We would get 2 times 0, which is 0, minus 1. Well, 0 minus 1 is negative 1. So that tells me at negative 1, I have my closed circle. And now I can use the slope to give me the rest of the graph here. So if I have a slope of 2, that means I would kind of go up 2 and over 1. Now the right side, you don't have to worry about going backwards because the blue line is allowed on the right side of the fence. Kind of like this. Okay. So the 2 ways I've kind of showed you how to do it. On the first slide, we made an XY table and we picked multiple points. Remember, you always have to pick the fence because you have to know where your open and your closed circles go. Okay, so I could have picked more x values less than 0. So I could have picked like negative 1, negative 2, plugged them in, plotted the points. That's fine. Okay, but as long as you just know what's happening on the fence, you can put those circles there and then use the slope to kind of direct you for the rest of the line. So if you're good at graphing, you can try that too. Okay, I'm going to have you guys try B. This is going to be the last one we kind of do today. So try B on your own. So take a minute and pause the video here. But draw your line on your fence at positive 1. So here's positive 1 on the X. And remember, your less than cannot cross that fence. It's got to stay on this half of your graph. Okay. And then your x minus 2 is when x is greater than 1. So that has to stay on the right side of the graph. It cannot cross the fence. Okay. So give that problem a try and see how you do. Okay. The graph should look something like this. Okay. So on the fence, if I plugged in 1, that would have been negative 2 plus 2, which would be 0. So you see I have an open circle on 0. And then that slope is negative 2. So again, we're used to going down 2 and over 1, but that would go on the wrong side of my fence. So instead of that, instead of going down and right, I can go up 2 and left and get the rest of my points. Okay, when x is greater than 1, so that's when we're going to use this function, x minus 2. If I plug in 1, 1 minus 2 is negative 1. So you see how they have their circle, open circle, again, because it's just strictly greater than, on negative 1. And a little imaginary slope of 1 says we just go up 1 and over 1. And that should give us the rest of our graph. So that's what a piecewise function is. It's graphing multiple functions together to form one picture. So piecing together functions to form one picture. Okay, we will practice this more together, but that's kind of your introduction to graphing piecewise.